In example 6, we are given that the lifetime risk of dying in a motor vehicle accident is 1 to 106. So that means one death for every 106 that survive. So that's 0.934%. So it's less than 1%. Suppose we randomly sample 500 people. That's going to be our sample size. So N is going to be 500. Let X be the number of people who die in motor vehicle accidents. So this would be in their lifetime. So a success is, in this case, quote unquote success, is that the person dies in a motor vehicle accident. The probability of that is 0.934%. So that's our P. So P is as a decimal. Remember, you always want P as a decimal. 0.00934. Got to move the decimal 2 places over. So we want to compute first the mean and the standard deviation of the distribution. So this is a binomial distribution, only 2 outcomes, either they die or they do not. All of the samples are identical, all the trials are identical. Probability of success is the same all the time, so probability of death is the same all the time, and the trials are independent. So they're independently people picking these people because it's a random sample. So our mean for binomial distribution is n times p. So we're going to take that 500 and multiply it by 0.00934. So 500 times 0.00934. So 4.67. So out of 500 people, approximately 5 would die in their lifetime, is what that's saying. And then our standard deviation is the square root of NP1 minus P. So that's going to be square root 500 and then 0.0934. And then times 1 minus that. Let me bring this down. So 1 minus 0.0, need an extra 0 in there, don't I? 0.00934. Let's compute that. So second square root 500 times 0.00934, and then times some parentheses 1 minus 0.00934. Close our parentheses up. 2.15. So mean of 4.67, standard deviation 2.15. Compute the probability that at least 6 people would die in motor vehicle accidents. So this is asking what's the probability that X is greater than or equal 6, at least. So 6 is the least, anything bigger is acceptable in terms of what we're looking for. Binomial probability, the calculator can only give you equal or less than equal. So we have to write this as 1 minus the complement probability. If you're not greater than or equal 6, you're going to be less than or equal to 5. So strictly less than 6, less than or equal 5. So now we can use the distribution calculator. So we're going to do 1 minus second variables. Scroll down to binomial CDF, which is option B. Our trials are 500. And our P, 0.00934. And then X is equal to 5. We want less than or equal 5. Oh, I've got one too many zeros in there. Let me just delete one of those out. There we go, 0.00934. So 3261 to 4 decimal places. So approximately 33% chance. Is it more likely that 4 or 5 people will die in motor vehicle accidents in their lifetime? Why? Well, let's look at the probability of 4 deaths and the probability of 5 deaths. So now this is exactly equal, so these are going to be binomial PDF. So you use PDF if you want one value, CDF if you want less than equal. So we use CDF for this one. So let's find these two probabilities. So we want to do second variables. Come down to choice A, binomial PDF. Trials are 500. P 0.00934. And then first we do x equal 4. And that gives us 0.1864. And now we go back and change it to 5. So we can do second variables, come down to PDF again, and then just scroll down and change our x to 5. And paste and enter. 1743. And we want to know which is more likely. That's going to be the higher probability. So 4 deaths are more likely. Because the probability is higher. And again, that's because probability of 4 is 0.1864, which is greater than, actually strictly greater than 0.1743, which is the probability of 5.